Hi everyone, in this video we want to talk about evaluating and simplifying expressions. So in this video we're actually going to introduce variables, talk about what are they and why do we have letters in mathematics. Okay, get into that a little bit. We're also going to talk about what is an expression, what is a constant, what's a coefficient. So we're really going to explore a lot of terminology that's going to be so important for the rest of the quarter because you need to know this terminology to be successful in future weeks. We're also going to talk about how to evaluate an expression, which will help us when we get to equations to help check our answers. We're also going to talk about simplifying expressions and how do we simplify things. Everybody likes their life a little bit simpler. So let's begin with our variables. So the basis of algebra is sometimes that we're given certain pieces of information and other pieces of information is left out. These are our unknown values, and this is common in everyday life, right? I go to the grocery store, I'm not exactly sure how much I'm going to spend, so that would be my variable. I don't know what it's going to be. I have an idea, but I don't know for sure. That would be a variable. So we have to introduce something more than numbers and operations. We need to include variables, and variables are your letters. So I really want you to think of these variables as placeholders for numbers. We just don't know what those variables represent or those numbers actually are. So variables are letters that represent our unknown value. So in middle school or when you were younger, you probably did things like 2 plus some number equals 5. And you would go, oh, that number is 3. Wahoo! Well, in algebra, instead of having that blank spot or even a question mark, what we do is we change that unknown value to a variable. Here we're using the letter X, and X is often the most common variable we use, but it could be any letter. Pick your favorite letter. I like A, just because my name starts with an A, so I'm a little biased on that one. But you can see here they're saying 2 plus some number, I don't want to know what that number is equal to 5. So what is the value of that number here? What could we put in for X? And you would say, oh, we can replace X with a 3, and that creates a true statement. Now that we have variables or letters, we can combine that with our numbers and operations to create expressions. Now, expressions are anything that you see on the screen that has a number, operations, variables, and any kind of combination of those three ideas. So for example, you have 3x squared, you have 3x plus 2. All of these are expressions. Notice that in all of these expressions, there's no equal sign. If there's no equal sign, that means we're not solving. We can only do two things, which we'll get to in a moment. But before we jump to that, let's go through a little bit of vocab. So some vocab that you should know that I'm going to be using so much. It's basically going to be used the rest of the quarter. The first one is a constant. What do you think of when you think of constant? Constant is something that's not changing, doesn't alter. So a constant is just a number by itself. So 3, 5, 10, 12. What's a number by itself? That's going to be a constant. Now, a number that's being multiplied or attached to a variable is going to be called a coefficient. And I like to think of that co to kind of tell me it goes along with. So it goes along with my variable. So a coefficient is the number in front of your variable. So for example, we said that a constant is just a number by itself. So maybe like plus 5 or minus 12, something like that. That would be a constant. Whereas a coefficient has to be attached to a variable. So maybe you could have 9x or negative 30x. I don't care. Pick a number and put it in front of a variable. That's going to be your coefficient, the number in front of the variable. Now here we have an expression, 5x plus 3. What I want you to do is I want you to take a moment and try to identify the constant, the coefficient, and the variable in this expression. So take a moment, maybe you want to pause the video and try it on your own. Okay, hopefully you got a moment to try to identify your constant, coefficient, and variable. So let's go through it. So here we have 5x plus 3, or you could read it as 5 times x. If there's no operation between them, it's an assumed multiplication. So 5 times x plus 3. So the number in front of our variable we'll refer to as our coefficient. I had to change colors because I was not happy with that red. Makes you feel like you're doing something wrong with red. And then x is our letter, which is our variable. We call it our variable. And then the number at the end is our plus 3. It's not attached to a variable. It's being added on at the end. So we're going to go ahead and call that our constant. So these vocab words are so important. Please practice those. Maybe grab your husband or your kids or your best friend and go, what's a variable? And practice with them and really annoy them so much as you're going through this math class. They'll probably be excited. It's exciting to learn new things. So as I said previously, there's two things you can do with an expression. The first thing you can do is to evaluate this expression. Now, to evaluate an expression means that you should I like to say it's plug and chug, meaning you're plugging your value in and you're chugging your answer out using the order of operations. So when people ask you to evaluate and they give you a number value, you're going to go ahead and plug that number in for the variable and then simplify using order of operations. And there's a video previous to this if you're unfamiliar with the order of operations. Now, the other thing we can do is we can simplify this expression. Now, simplifying an expression comes with two steps. The first step is to get rid of the parentheses by taking whatever's multiplied in front and distributing it into your parentheses or multiplying it in. The second step is to combine your like terms. And we'll get into what this means. So here we have a couple of examples that we're going to walk through. Feel free to work ahead if you're feeling confident and you remember this. Or if you want to just follow along and then try some problems later, you can do that as well. So evaluate the following expression. So in this first problem, we have the expression 20 minus 4d, or 20 minus 4 times d. And they're telling us that d equals 6. That means we need to take 6 and plug it in for d. So we're going to replace d with 6, and our expression becomes 20 minus 4 times 6. We've replaced d with 6. Now that we've done that, we can go ahead and simplify by multiplying first, because remember in the order of operations, multiplication comes before subtraction. So we have to go ahead and simplify this part first. 20 minus 24, 6 times 4 is 24. And now we can go ahead and subtract, which will give us a nice -4. And we've evaluated that expression for when d equals 6. Okay, let's try that again. Here we have the expression 8 times the quantity 2n plus 20 for n equals -12. We have a negative to work with. Always good practice to walk through negatives and make sure you're doing it correctly. So again, we're going to replace n with -12. So this n right here needs to take a hike, and we're going to replace it with -12. So 8 times 2 times -12. So I replaced n with -12. Just wrote down the rest of the problem. I don't know why I made that 20 so large. We'll rewrite that. There we go. Beautiful. n is replaced with negative 12. We're multiplying these two, this coefficient and this variable. So I change that to multiplication. Order of operations, got to do parentheses first. Inside the parentheses, we have to do multiplication. So this becomes 2 times negative 12 is negative 24. Again, add what's inside those parentheses. Negative 24 plus 20, we actually did it up there. It's negative 4. And then finally, what operation is happening between these two? Remember, if there's no operation that you see, you assume that it's multiplication. So 8 times negative 4 is negative 32. Boom. And you are done. So we've evaluated this expression for n equals 12, and we've got negative 32. Try some extra other problems like this. Try to plug in different values for your variable. See what you come up with. Now that we have evaluating done, we can move on to combining like terms. So what is a term and how do we combine it? Well, the coefficient, variable, and exponent combine to form a term. So some examples are 7y, 5x, negative x, negative 12z, and you could keep going up with those. You know, you could make it like 5x squared or something like that. Anything with a coefficient and a variable and a number or some combination of those. Now, we really care about the like terms. That's what we really care about. So what are some examples of like terms, or what are considered like? Well, I've got to write them out. So let's say we have the term 7y. Let's start with 7y. What is a like term for 7y? Well, it's any term that has the same variable and the same exponent. So something that would be a like term for 7y would be 12y. It has the same variable and neither one have an exponent. So they're considered like terms. They just have a different coefficient. Another like term to 7y could be like negative 3y. Okay, it has the same variable, it just has a different coefficient, which is fine. We don't care what the coefficient is. Make up your favorite number, plug it in as a coefficient, and you've got a like term. Now, let's try something else. Let's try an exponent, 5x squared. What's a like term to 5x squared? Well, same thing. Anything where your variable and your exponent are the same, only your coefficient has changed. So you could have 200x squared, or you could have negative 1,250x squared. I don't care as long as it has that variable and exponent. I don't care what the coefficient is. Okay? Now, one extra thing, so these are all like terms and these are all like terms, but you can't go between those, okay? Something that's not a like term for 5x squared would be like 12x. That would not be a like term because there's no exponent here, so it doesn't match the like term requirements. Some other like terms are any constants by themselves. So if you just have, I don't know, let's say 9 by itself. That's a constant. It's not attached to a variable. So that means it is a like term to any other number or any other constant. So, and 112, I don't care, and negative 604. I don't care. Pick a number, any number, and it's going to be a like term to 9. And like terms are important because you can actually combine like terms. And you can combine like terms by simply adding or subtracting their coefficient. So we're going to take those coefficients, we're just going to add those together, keep the variable, and you've got our combining like terms. So in our first example, we have 7n minus 12n. The first thing you want to do is make sure that your two terms, and terms are separated by addition and subtraction. So here we have a subtraction separating the two. 7n minus 12n, they are like terms because they both have the same variable. So we want to go ahead and combine their coefficients. Now it's very important here that you notice the first coefficient is a positive 7 and the second one is a negative 12. When we add those together, 7 minus 12 is going to get you negative 5n. Notice I added the coefficients and I kept your variable. Now, if you're unsure, you can always type that into your calculator. Just do 7 minus 12 and you'll see you get negative 5. You can do that as well. Don't be afraid to have your calculator handy. That's fine with me. It's not a problem. So we've simplified this by combining the like terms. So it's just negative 5n. We're not actually solving for any number at this point because we don't know what the value of n is. So for our second example, we have 4x plus 3 plus 5x minus 7. So we need to combine the like terms. So we really need to understand which ones are the like terms. Let's start with 4x. What can I combine the 4x with? What is a like term that I can combine it with? Well, I can go ahead and combine it with my 5x. So 4x plus 5x, you're combining the coefficient. 4 plus 5 is 9x. Now we have some constants here as well. So plus 3 and negative 7. Constants can be combined as well. So plus 3 minus 7, add those together, you get negative 4. And this would be your simplified expression, this 9x minus 4. So you've simplified it. Make a note to yourself that you cannot add the 9x and the 4. Why can't we add those together? Well, they're not like terms, right? One has a variable, one does not. They do not combine. Apples and oranges, we're not going to combine them. Okay, for C, let's go through our last example of combining like terms. So 8x squared, what can I combine that with? What should I combine that with in this expression? Well, I've got to combine it with my other x squared option, which is negative 7x squared. Bring those together. 8 minus 7 is going to give you a 1x squared. Now, we actually don't need to write the coefficient of 1 if we don't want to. Either way, it's fine. I'm going to go ahead and write it in just so that we remember when we go back in our notes and remember, oh, we took 8, we subtracted 7, we got 1. Now let's look at the next term, negative 9x. Well, who am I going to combine that with? Can't combine it with our constant. Those are not like terms. Can't combine it with our x squared. We don't have the same variable. Not going to work. So it looks like I can only combine it with my other x term, which is plus 5x. So negative 9 plus 5 is going to give you negative 4x. And then last but not least, we have our constants, which we need to add together. We have a positive 3 and a negative 8. Positive 3 minus 8 is going to get you negative 5. Yes. Okay. This is what happens when it's just me in a room by myself. I always double guess, double check myself. That's why I always encourage you, double check on your calculator. Can't always trust yourself. Okay, so our final answer is x squared minus 4x minus 5. We can't combine anything else. There's no like terms that we can bring together here, so we're actually done. And I think that's the hardest part, is knowing, when am I done? Well, when there's no more like terms to combine. You've got to teach yourself to say, I'm done, we can stop. So the next property we want to talk about is the distributive property. And this is actually the first part of simplifying, but we teach it second. You'll see why in a second. But to simplify an expression which contains parentheses, we're going to use the distributive property. So if you have parentheses, The only way to get rid of those parentheses is to take what's outside, out front, and is being multiplied, and to multiply it to each term on the inside of those parentheses. So let's see what that looks like here. So here we have 7 times the quantity, m plus 3. Now normally we would look inside those parentheses and we would say, oh, I want to add these together. But there's a problem. What's the problem with adding m plus 3? Well, they're not like terms. M is a variable, 3 is a constant. We can't add those together. Can't do it. So we can't simplify that. The only way to get rid of those parentheses is to take what's being multiplied out front, which happens to be a 7, and multiply it to each term inside those parentheses. So let's take the 7, multiply it by the m, and take the 7 again and multiply it by the 3. So 7 times m is 7m, and 7 times 3 is 21. Notice we dropped the parentheses, and now we have 2 terms. They're not like terms. We can't combine them, so we're done. Adios problem. Now for our next problem, again, we want to get rid of those parentheses. We can't add what's inside. One is a constant, one's got a variable attached. They don't combine, so we need to take what's being multiplied out front, which happens to be a negative 8x, and we're going to multiply him inside to each term. Notice there's 2 terms. Again, terms are separated using addition and subtraction. So negative 8x times 2, one negative multiplied stays negative. So this becomes negative 16x. And negative 8x times negative 3y. 2 negatives multiplied becomes a positive. 8 times 3 is 24, and x times y is just xy. Now these 2 terms do not combine, and the reason for that is that they do not have the same variables. They have to have identical variables. And right now this one has an x, only an x, whereas this one has an x and a y, which we can't combine. So we can't do anything else for right now. Check mark, done, moving on again. So the next one kind of tends to freak people out because you're like, fraction! I hate fractions! But luckily we can use our handy dandy calculator. Now I have a graphing calculator, but you don't have to have a graphing calculator. As long as it's scientific, you're good. So here we want to take the fraction that's in front of our parentheses and we need to multiply it. Now I'm going to multiply it to all of my terms. Notice there are 3 terms this time inside my parentheses. And how I'm going to do that is I'm just going to use my calculator and type in 2/3 times 3. How do I do that? Well, if you take 2 and hit the divide button, it's a divide button, boom, 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 divide, boop, boop, boop. Notice that the divide button looks like a fraction. That's not a coincidence. It represents a fraction. So 2 divided by 3 times 3. So 2 divided by 3 times 3. And you get 2. So 2/3 times 3x is 2x. Now let's do the same thing for the other 2 terms. So 2/3 times negative 12. Well, we know it's going to, one negative stays negative. If you don't remember the negative rules, make sure you check out my other video as well. So 2/3, 2 divided by 3 times 12. 2/3 times 12 is going to get you 8. So it's going to be negative 8. Then last but not least, let's go ahead and take 2/3 and multiply it by 9. So 2 divided by 3 times 9 is going to get you 6. 2/3 times 9 equals 6. So this turns into 6y. We always want to remember those variables. Now, as you notice, we've gotten rid of those parentheses. We've actually gotten rid of our fraction as well, which is super exciting. Woohoo! But now the only thing that we want to double check, are there any like terms we can combine? They all have different variables, so the answer is no. Can't do it, so we are done with that problem. Woohoo! Now, the last thing that I want to do in this video is I want to go ahead and combine the last two ideas that we talked about into simplifying an expression. So if you're doing some problems and the problems ask you to simplify an expression, what that means is they're really asking you to, one, use the distributive property to get rid of any parentheses, and then two, combine all of your like terms, and then you will have simplified your expression. Let's go through an example. So here we have several examples, but let's start with A. Don't worry about the other ones. We'll get there later. No worries. So the first problem is 5 plus 6 times 8x minus 1. Step one, distribute. That is terrible handwriting. Okay. That means we need to go ahead and get rid of these parentheses by taking what's multiplied out front, which is a positive 6, and multiplying it in. Okay. Notice I ignore whatever's outside. I don't care. I just drop it down. I just want to go ahead and multiply 6 times 8x, which is going to get me 48x. And 6 times negative 1, which will get me a negative 6. Now, what can I combine here? Because step 2, combine like terms. It's really a two-step process. There's nothing really beyond that. So here, what are our like terms? Well, we have an x term. There's no other x term, so we're just going to drop that down. But we do have constants, 5 and negative 6. Let's go ahead and add those together. 5 minus 6 is going to get you negative 1. Now double check that you've added together all of your like terms and there's nothing left for you to do. So there's an x term and there's a constant. Can't combine them, so we're done. Check. We're good to go. So for this next problem, we're going to start the same way we did before. Step 1, let's go ahead and distribute. So what we're going to do is we're going to take the number outside of the parentheses and multiply it in. Notice I'm only multiplying it to what's inside those parentheses. Notice I don't do anything with that negative 9 because it's outside of the parentheses. I don't care about him right now. He's going to have to wait his turn, okay? We'll deal with him later. So for now, let's go ahead and multiply. And we know how to deal with fractions now. We just got our calculator, boom, plug it in, done and done. So the first one is 12 times 2/3. So 12 times 2 divided by 3 is going to get you 8. So 12 times 2 divided by 3 is 8. So we have 8x plus, and again, 12 times 3 divided by 4. 12 times 3 divided by 4. And that will get you 9. 12 times 3 divided by 4. Now we're going to go ahead and drop down this minus 9. Don't worry, we said he'd come along for the ride. We just weren't dealing with him at that moment. Okay, he had to wait his turn. So the next step is to combine any like terms. Well, our 8x we can't combine with anything. The other two don't have x's in them, so he's just chilling by himself. Now, these two are constants, plus 9 and negative 9. When we add those together, what do we get? Positive 9 minus 9. Well, it's going to come up out to 0. Well, what does adding 0 do to a problem? Does it do anything? If I add $0 to my bank account, am I doing anything to it? No, I'm not. So we can actually just drop this and just make it 8x. basically the 0. You don't have to add it on. In fact, you can skip this middle step. That's fine as well, and just move to that 8x if you're comfortable with it. Okay, almost done. 2 more problems to go through. We can do it though. We have the tools. We know how to attack it. Now on C, we see that we have a lot going on. We have 2 sets of parentheses and we got some fractions. But of course, we go back to our steps and we go, well, what's step 1? We need to go ahead and distribute. We need to get rid of those parentheses. So I'm going to go ahead and highlight those parentheses and say I need to take what's outside and multiply it in. Sometimes colored pencils are your friend in this class. Just a thought. Same thing with the second set of parentheses. I'm going to take the number that's out front, that 1/3, and I'm going to multiply it to each term. So 1/2 times 8x, again, plug it into your calculator. 1 divided by 2 times 8 is going to be 4x. And likewise, 1 divided by 2 times 10 is 5. Once I've multiplied that in, I'm going to drop those parentheses, and I'm going to move on to my next set of parentheses. 1 divided by 3 times 9x is a positive 3x. 1/3 times 15, 1 divided by 3 times 15 is going to be a negative 5. It's going to stay negative since this is a positive. 1 positive, 1 negative stays negative when you're multiplying. And then last but not least, this guy, this negative 7x, has just been chilling. He's not in any parentheses. He's not multiplying anything. So we're just going to drop him down. He's been patient. So now let's go ahead and move to step 2, add our like terms together. So we have some x's that we want to add together. This time we have 3 x's that we should add together. So 4x plus 3x is going to be 7x minus 7x. Oh no! What's 7x minus 7x? That's going to be 0x, or 0 times anything is 0. So those two, all of these are actually going to cancel each other out and turn into a 0. And then we're going to go ahead and combine our constants, 5 and negative 5. What's the problem there? It's also 0. 5 minus 5 is 0. So 0 plus 0 is 0. This was a weird one. I did not realize that it did this, but hey, everything canceled, so it's 0, okay? When we add and subtract, when everything cancels, it just becomes a 0. So that's all we want to write there. Okay, last one. I think this one actually looks a little bit easier than some of the other ones we've done. So give that a try. If you're feeling confident or you want to give it a try to see if you're on the right path, pause the video, try out the next problem, and then see if you got it right. Come back. Okay, so in this last problem, we have 2 sets of parentheses. In the first parenthesis, we want to multiply in 5. So we're going to go ahead and do that real quick. We don't have to worry about fractions or anything like that. So 5 times 3x is going to be 15x. And 5 times 10 is negative 50. Wahoo, that was not so bad. Not so bad. Now in the second set of parentheses, I want you to be careful. This is what a lot of students miss. They're like, oh, we need to multiply in the 8. Close. We need to actually multiply in the negative 8. If there's a negative out there, we do have to multiply by that. So in this example, we're going to multiply a negative 8 times a positive 2x, which will stay negative and become a negative 16x. Again, negative 8 times negative 1, 2 negatives multiplied will get you a positive 8. Now I'm going to go ahead and combine my x's. So 15 minus 16x is going to give me negative 1x, or I could write that as negative x. That's fine as well. And then I want to take my constants and add those together. Negative 50 plus 8 is going to be a negative 42. and then we are done. Because we cannot add those together, they are not like terms. So let's just be careful about that. Remember, you could have written this as negative x minus 42. You could have also put the negative 42 first and done the x second. All of these are equivalent. All three of these statements are equivalent, meaning they're the same thing. They say the same thing. They're just written slightly different. So just a heads up. So just quick summary. Expressions are composed of numbers, operations, and variables, which are letters. And we can either evaluate or simplify expressions. You evaluate an expression by plugging and chugging. Plugging in your value and simplifying it using the order of operations. Make sure you review those if you need to. Wink, wink. And then simplifying is our second thing we can do with expressions. And simplifying is what we just got done doing. Getting rid of parentheses by using the distributive property. And then combining your like terms. And like terms are where you have your same variables and same exponent. Note, one mistake that happens every now and again is that people try to solve and find the value for the variable, but expressions cannot be solved, okay? They can only be evaluated or simplified. There's no equal sign, meaning you cannot solve them. Don't try it. Okay. And then simplifying expressions is so important to us because it's going to help us when we get to equations and solving, eventually, when we get to solving equations, which is actually the next video. But it's going to help us with that because it's actually like the first step. So good luck. Make sure you practice simplifying because it's one of those necessary skills to have to be really strong in mathematics. So practice, practice, practice. You'll be using this throughout the quarter, and you will definitely be using this for the next video, which is solving equations. So good luck, and I will see you again soon. Bye.